wait for 10 more minutes for others to join and then we'll start the session.
Yes, ma'am.
I've already shared the PPT. Is the is the question answer PPT and the notepad visible? Okay, fine. So let's wait for 10 more minutes. Once other join, then we'll start with a discussion session for whatever was taught. Like I won't go to the detail, but we'll get a brief of what happened in the previous classes, what sir taught in class, and then we'll start with a few of the questions, a problem solving session. Okay? Wait for
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Hello.
Yes, ma'am.
Yes, yes. I think we should start the class. Okay,
Yes,
so
ma'am.
let's get a brief of what was already taught in the. Someone joined. Let's get a brief of what was taught in the earlier class by sir. So, first we'll talk about the concept of center of pressure. So, have you taken the classes?
No, ma'am.
Priyanka, have you taken the classes? Okay. So, what do you understand about the center of pressure?
It is the point about which the uh, all the pressure forces act.
Yeah, correct. So, okay. So, if a body is placed on a flat plate, like let's suppose there is a fluid, okay, and here we have placed a body like that, and this is the pressure force. As we know, like as the depth will be increasing, the pressure will be increasing because of the hydrostatic weight of the fluid above it, right? So let's suppose if it is a distance, the body is a distance depth, at depth of a distance from the surface, from the free surface. This is the free surface, right? So, and this is the z direction, this is the height of the body. So if this is the center of gravity of the body, what do you think that center of pressure would be above it or below it for the body to be in equilibrium?
Below it, ma'am.
Yeah. So, mm, let me use some different color. So, center of pressure would be here. Center of pressure, what does that mean? It's like there is the pressure is a distribution force, right? It is because of the distributed effect of all the forces acting on the body. So if we consider that at a point, like if we think that, if we let's suppose that all the pressure that is acting, or the pressure distribution that is acting on the whole body because of the fluid that is present here, if we think that it is acting on a point, then it is called the center of pressure. So if we think that like this is the pressure, like the change in pressure with the height, so this is equal to rho g, as sir have already taught this in the class. So this will be rho g z plus some constant, so this will be the pressure at the free surface plus rho g z. So this is the pressure at the free surface, right? And this is the depth. So as the depth will be increasing, the pressure will be increasing. Now let's go to the brief of how we should get the forces, and like, see, we have to know like what is the distance of this center of gravity and this center of pressure from the free surface, right? So that is most important thing in this calculation. So if a body like if a body is tilted also, or if a body is placed at any place on a fluid, then we should know, we should have an idea of how to find out the center of gravity and how to find out the center of pressure. So that will give us an idea of like if a body, if a force is exerted in a body, like if a body is tilted off, or any pressure is applied, then how about we should go around to get the calculations. So if a body is like if a body is floating also, if a body is partially submerged also, there will be the like when we will be tilting it, the as we will see in the later parts of the class, that the pressure will be like the pressure, or the pressure center of pressure will be changing if we will be applying force on this side, right? So as we can see, so for the basic state, like when the body is in equilibrium without any external force being applied, we should know how to find out the center of pressure and the center of gravity, so that to understand whether the body is in equilibrium or not. So let's start with what sir taught in class. Like if there is a free surface, and like this, a surface is there, that is submerged in a fluid, and if we extend it, this is the angle theta. This is let's suppose point x, and this height is hc is equal to yc sine theta. This is theta, right? So from here it is yc sine theta. Yc is what? Yc is the distance of this body. Like if I take a, like if let's suppose this is the body, right, and I take a small element here. So this, if this is the axis of rotation, let's suppose this is an arbitrary frame. Later on we'll change it we'll change this axis with respect to our point, like the axis of rotation. But for now, let's suppose this is the arbitrary axis of rotation. Like from here we'll get all the calculations. Like if we will be tilting the body also, this will be taking place. The pivotal line will be this line, right? So let's suppose we are taking a small element, and if we are taking a small element, then this, let's suppose this is the center of gravity, and this center of gravity the distance from this to the axis of rotation is yc. And if let's suppose this is the pressure, the center of pressure, this will be yp, right? And the vertical distance of this yc from the, like this yc, like if this is yc, right? So its vertical distance is yc sin theta. Simple. So if we'll find the force that is acted on on this body, so the elemental force that will be acting on this elemental area, that will be the pressure into dA. Simple, the pressure into area on this small elementary area. So pressure is what? Pressure is rho g y sine theta, like y sine theta, like basically rho g into h sine theta, sorry, h into area, right? So this h we have converted into y sine theta, simple. So if we will be finding the whole force that is acting, so we have to do what? We have to find the integration. So we'll be integrating it, and if we'll be integrating it, this will be rho g sine theta, and this is y dA, right? So YC will be coming out to be integration of area y dA upon A. So if we will be if we will be integrating this force, so this is YC, right? YC is what? YC is for this whole area. If we will be just integrating with respect to the whole area, that will be YC. So if we will be finding the whole force, that will be rho g area into YC into sine theta. So this is simple AC. So rho g A AC. Okay, but this is a distributed force. So we need to find a point through which this distributed force will pass. So the point of application of this distributed force, let's suppose this point P, as I have already told, that is the center of pressure. So we need to find this YP now, this YP. So YC we have found out. Now we need to find out YP. So if we consider that an axis with respect to which you take a moment of forces, like this axis, as I've already explained you, this axis they have considered. So this, about this axis, the moment of all forces is being considered. Then the moment of resultant force with respect to the axis is the summation of the moment of individual component of that forces with respect to the same axis, as per Waringin theorem. So we use that to find YP. If, see, if this F is the resultant force, and then the moment we will take the moment about, if we will take the moment about this x-axis, this arbitrary x-axis. So if we will take that, then FYP will give the what? The magnitude of moment of that force. We need to find the moment, right? So magnitude of moment of that force F will be given by FYP. So F we already know. So this will be integration of y df. So this we already know as rho g y sine theta. This is yc sine theta, right? So y sine theta into y and dA. So this is equal to rho g sine theta integration of whole area y square dA. So this is what? This is nothing but second moment of area, Ix. So this sir already told you. I am just giving you a brief of this. If you won't understand anything, you can simply unmute yourself and interrupt me and tell me like which portion you are not understanding. Okay. So now this yp is equal to simply like rho g sine theta. This is the moment of the second moment of area. So this is Ixx upon F. Right now, F we already know as what? F is rho g a y c sin theta. So yp is equal to rho g sine theta Ixx upon rho g a y c sine theta. So this will be Ixx a y c. Now Ixx is equal to, now we will translate this. See, which arbitrary x-axis we need to take, we don't know. So that's why we will take such a line that will be passing through the centroid. Let me give some other color. So this will be passing through the centroid, right? So this point C, not this one, sorry, this point C. So we will take such a line that will be passing through the centroid of the body. So for this we will use just the parallaxis theorem. We'll just shift this axis to this axis. So how we will do that? We will just, if we will do that, so there is parallaxis theorem which will give that the second moment with respect to the centroid plus area into yc, that is the distance from that
Right.
axis. Yes, Sonalika, you want to say something?
yes yes मैम वो बोल रही थी वो ए वाई सी स्क्वायर
Yeah, correct. So just one second. Yeah, so from this, if we will find yp, that will be ixx, means ixx will be replaced by this ic ayc square upon ayc. So this will be simply yc plus ic ayc, and this will be yp. So this point is called center of pressure, this point P. This is just the distance of the center of pressure from the centroid of the body. So obviously the point through which the resultant of all distributed forces due to pressure passes is this center of pressure, and this yp should be greater than yc from the free surface, like everything we are measuring from the free surface, right? So this should be greater than this for the body to be in equilibrium. And this is also evident from this formula, right? Because second moment will always be positive, area is positive, and yc is also positive. So obviously this yp will be greater than yc. So that means what? The centroid of pressure in this diagram, the centroid of pressure, just one second, yeah, the center of pressure, the center of pressure, this P will be below the C. So this is evident from the diagram and from the derivation as well. Okay, now if we will do the same thing for curved surface, what we'll find out, like, we won't go for the derivation, but I'll give you a brief explanation or idea about what is happening. So if this is a curved surface, for any curved surface, like what we will do, if a curved surface is immersed on a fluid, what we will do, we will take the projection of that curved surface, that means volumetric projection. Like if this is a curved surface, this is not just a this is not just a simple line, right? This is like this. So it will be whole volume of that surface, whole surface into the board or paper or whatever the notepad may be. So this will be like that. So what we will do, we will take the whole volume, that means this whole volume that is above that curved surface. We will take the pressure of that whole volume acting on that whole volume to determine the pressure that is acted on this curved surface, right? So let's suppose this is vertical force, and this is the horizontal force. This is the force. First we will calculate or derive rather the force that is acted by the surface on the fluid, right? So what will be the force that will be acted by the fluid on the surface? That will just the opposite of this, equal and opposite. So if we will take, like, this is the fluid element. Let me rub this and make it some clean. So this is the surface, this is the free surface, and this is the fluid element. Volume of fluid that will be considering, like over which the forces will be over this, all the forces will be considered here. So let's suppose this is the force due to the fluid element that is present on this left side, right? And this is the surface. So there, it like there is some mistake. Just 1 second. Let me clean it up first. So this is the curved surface. So we'll take the horizontal, sorry, vertical projection, right? So if we will take, this is the vertical projection and this is another vertical projection. So we'll take just the volume of that. So this is the volume of the fluid. So this is one straight line and this is one straight line. First we will find the forces on these two straight lines, right? So this is on the left side and this is on the right side. Like this is all the fluid, the force applied by all the fluid on this surface, right? So this is, let's suppose, F of H2. And what another force is, vertical force is that this is for the weight of the fluid element. Now, okay, just 1 second. Now, we are interested on the forces that is acting on this projected volume, right? So let's zoom this up. So this is the free surface. This is the body. This is the volume that we are taking into consideration. Just 1 second. This is the volume that we are taking into consideration. Okay. And this is the weight. This is the vertical force and this is the horizontal force. Okay. So this is because of what? This is because of the components, because of the reaction between the surface and fluid. So these are the final components, right? So this is FH1, as I already told. For this fluid bit on the left side of this surface, there will be the pressure exerted on this side of volume, like volume, projected volume rather. So this is H1 on, and this is FH2 on the right side, that is acted on the right side. Okay. So AB and CD are plane surface. CD, let's suppose this is CD and this is AB. So AB and CD are plane surfaces. And now, if we will find out, if the fluid is in equilibrium, then the summation of all forces in x direction will be 0. So in x direction, what are the forces? First is FH is one force due to the reaction. Yes, Sonalika?
Yes, ma'am. H1, FH2 and FH.
H1 and H2.
FX
Yes.
direction.
Yes, correct. So can you tell me the signs of that? Like how we will find that out? FH is on left side. So if we are giving that positive, then rest.
Ma'am, FH1 positive and FH2 negative.
Yeah, correct. So FH1 minus FH2 is equal to 0. So this horizontal force will be minus of FH1 minus FH2. Now, can you tell me Fy, summation of Fy, like what are the forces on y direction from the diagram?
Then W and F.
So, what are the signs?
Um,
FB,
FB minus.
Yeah,
Positive W minus W is equal to 0.
yeah. So FV minus W is equal to 0. So FV is equal to W. What does this denote? That only for the vertical component, the force is given rise only by the weight of the fluid, right? Only by this weight of the fluid, the force is given by only by this weight of the fluid of the projected volume, this projected volume, right? And for the horizontal case, there will be a difference between the horizontal component for the left side of fluid and the right side of fluid. So like make sure that this whatever we have calculated here or we have denoted here, these are the forces that is applied by the fluid element under consideration to the like this surface, rather this surface to the fluid, outside fluid, right? So what we need to find, we need to find the forces that are acted on the curved surface. So that will be nothing but minus FH and minus FP, just the equal and opposite. Okay, so now let us talk about stability of floating and submerged bodies. Okay, so can anyone tell me what are the factors that determine the stability? What are the forces that will come into action? Like what do we, yeah, tell me, Priyanka.
Weight and buoyancy forces.
Yeah, and what are the things that we consider to determine whether a body is stable or not?
The center of gravity and the center of buoyancy.
Yeah, yeah, correct. So so there will be, like, let's suppose if we take a body into consideration, let's suppose this is the free surface. Okay, so this is a body that is completely submerged onto the, like, completely submerged onto this fluid. So this is the center of the body. If this is the center, then let's suppose this is the center of buoyancy. If this is center of buoyancy, and this is the center of gravity. So center of gravity will denote by the will denote the force, the weight of the body, and this will give rise to the buoyant force. Okay, so let's suppose this is OP and this is OG. So there are two cases, that is, one is stable, another is unstable case. So can you tell me, like, in the stable case, which one will be, like, whether B is above G or G is above B? Anyone?
B above G, ma'am, in stable case.
Yeah, yeah, correct. B will be above G for stable equilibrium, and for unstable, vice versa. So can you tell me, like, what does stable, like, I'm using the word stable equilibrium again and again. What does that mean?
Means if we like rotate an object from its equilibrium position, if
Hmm.
it is stable, then it will come back to this that equilibrium position.
Hmm. Because all the forces will be directing to that direction, right? Like
Yes, ma'am.
opposite to where we are giving the force. Yeah. Anyone else? Any other point of view? Pawan? Sonalika? Tell me. Anything that you understand. What?
मैम और एक बार क्वेश्चन है थोड़ा समझ में नहीं आया।
I am asking that what do you mean by stable equilibrium? I am telling the stable equilibrium again and again. What do you mean by the stable equilibrium? If a body is completely immersed on a fluid, what does stable equilibrium means over that case?
All the forces are balanced.
Huh? Forces are,
Ma'am, all the force acting on that body should be balanced.
but that is fine. That is fine. But if we'll, let's suppose if we will be giving some toppling, like we are toppling on one side of the body. So what does happen in case of stable equilibrium? What will happen?
Sorry, ma'am, no idea.
Okay, okay, not a problem. I'll tell you. Just one second. So, see, Bowen force will be always acting upward, right? So, let's suppose if this body we are just tilting it on right. So, let's suppose now the body, this is the free surface and this is the body. So this is the center of buoyancy and this is the center of gravity. So center of buoyancy, the force will be on the upward direction, and for the gravity it will be on the downward direction. So what does a couple means? Like here a body couple will take place. So what does this couple means? When there will be two force, if we will be drawing a perpendicular line, just one second, let me use some other color. Like if let's suppose we are drawing a perpendicular line, this perpendicular line will act as a couple for these two forces, right? So in this case the couple will be directing in this direction, that is anti-clockwise direction. So what is happening, we are giving force in the clockwise direction and the couple is acting on the anti-clockwise direction. So the body will come back to its original position after some time because of the stable equilibrium. So when two forces, like let me give you a brief idea of this couple, what this couple means. When the two forces are acting on the opposite direction respectively, to then this perpendicular line that we are, that is joining these two forces rather, that is called a couple, and there will be some specific direction where this couple will be rotating in order to bring the body into equilibrium. So in this case this the direction is anti-clockwise and as the direction is anti-clockwise, so what will happen, the body will come back to the equilibrium position. So, despite an angular displacement applied initially in the clockwise direction, because of the position of the center of buoyancy and the center of gravity, there is a restoring couple in the opposite direction, right? So, uh, do you have any doubt in this?
Yes, ma'am. Ma'am, can you again explain?
Okay. Uh, See, let's suppose this is a body that is totally, like completely submerged in a, just one second. This is a body that is completely submerged in a fluid. So if we will be like, this is the center for the, like the axis, right? Center of axis of the body. So let's suppose we are rotating it, or we are giving a force on this side by an angle theta. So the body gets rotated, like it will be rotating like this by an angle theta with the horizontal. So in that case, if it is doing like that, um, see, initially this was the Bowen force and this was the gravity. So both of them were like on acting on the same line, but when it gets toppled or when it gets rotated at some angle or some force is applied and it gets displaced from its initial position, what is happening now? Here this is the center of buoyancy and here it is center of gravity, B and G. This G is acting on the downward direction and this B is acting on the upward direction. Like let's suppose this is B. So
Ma'am, but initially they are acting in same direction.
not same direction. This was also downward only. Gravity will be acting downward, right? And Bowen force
Yeah,
will be
yes.
acting upward. So these
Upward.
are the
Yes.
two forces that will be balancing each other. But
Yes, ma'am. Yes.
previously it was the acting was on the same line of axis, right? But now these are on different line of axis. Like Bowen force is acting on this line and gravitational force is acting on this line. So when we are talking about couple, so we will draw a perpendicular line in between these two forces, nothing else. So this couple will have a net direction or angle where the displacement will be taking place. So this couple, as we can see, its direction is in the anti-clockwise manner, right? So this will move here in anti-clockwise manner. Anti-clockwise means this side. So initially we gave a displacement on clockwise and now it is moving to anti-clockwise. So that means it is going back to its initial position. That means it is in stable equilibrium. Stable equilibrium means when we are giving a displacement on some direction, it will be rotating and coming back to its original position. So that means it is in stable equilibrium. And if the body is in unstable equilibrium, then how like whether if we are giving some giving some force on some direction, the this moment will take place or the direction of this moment will also be in that direction. That means it won't ever come back to the initial position. It will be keeping on displacing, right? So have you understood that now, Sonalika?
Yes, ma'am. Yes, ma'am.
Yeah. Okay. So let us move to the next concept and then we'll start with the problems. So the next thing that we'll be discussing is stability of floating bodies. So what do you think that what is the difference between the floating body and a completely submerged body? What will be happening over there? What is the difference that will be happening?
Ma'am, in submerged bodies, the center of buoyancy will not change, but in floating bodies, along with like when position changes, the center
Mhm.
of buoyancy also changes.
Yeah, correct. Cause and can you tell me like why that will change?
Because the displaced volume it will change.
Yeah, like if a body is like if this is the fluid and if this was a body like that and when we will be applying force on this, like we'll tilting the body, this like if this is the body, now the body that is like the volume of the body that is submerged is changing, and because of that the buoyant force changes. Simple. The rest of the things will be same, just now the center of buoyancy was same in the previous example, right? But here the center of buoyancy itself will change. Now we will see some new center of buoyancy. So it will be shifting to a new position. Like let me give you an example. So if let's suppose this is a body. So this is let's suppose the center of gravity and this is let's suppose the center of buoyancy B1. This was initially at AB and this is B double dash. Now we are giving a slight force on this B double dash position, right? So what will happen? This will just topple. It will be like this. Now it is A dash and B dash, and this angle is theta. Now, as the volume that is inside, that means this volume, this whole volume, this is different now, right? Initially it was this, now it is this. So if this volume is changes, the center of buoyancy will also change, right? So initially, let's suppose the center of buoyancy was here, B1. Initially it was initial one, right? And gravity was here. Now it will move to here, or it will move to here. Tell me. I'll give you uh like way to explain this. What do you think? The center of buoyancy will move on the right side or left side? And if so, why? Anyone?
Since more volume is displaced on the right side, it will go to the right side, ma'am.
Yeah, correct, correct. Very good. So, yeah, so the new buoyant force center of buoyancy will be, just one second, new center of buoyancy will be on right side here, right? So can you tell me, here one term comes that is metacenter. What do you mean by that metacenter?
Like if we draw a vertical line to the point B dash,
Hmm.
then the point it will it will cut a point through which it will cut a point on the axis through which G passes.
Hmm.
That point is metacenter.
Yeah, and what is metacentric height?
Uh, GM, the length of GM.
Yeah, correct. Anyone else? Do you have anything to speak about this? Anyone? Should I explain this to you?
Yes, ma'am.
Okay. So what happens is that, let's suppose I'll draw this here. See, this is B. This is the axis where the body is, like all the center of mass is, and the previous buying force was there. So this is center of mass and, sorry, center of gravity, and this is the buoyant force. So the new buoyant force is here. It has shifted to here. Now, if we will extend it, so there is a point where it will cut. So this is M. So this M is called the metacenter. And this distance between the metacenter and this center of gravity, this will determine whether this body will be at equilibrium or not. So now what will happen? This distance is called what? Metacentric height. So tell me one thing, what will happen in this case, like in for floating bodies, what will be happening when we consider this term stable equilibrium? Like what will happen? What condition should we consider for stable equilibrium?
GM greater than 0.
Yeah, correct. So GM greater than 0 means which point should be above and which point should be below?
The metacenter point should be above the center of gravity.
Correct. So this means for stable equilibrium, M should be above G. And for unstable, the vice versa. So metacentric height is nothing but a way to denote the direction of the buoyant force that act along the center of the axis, right? So now this I've already explained to you. Now if what will happen, like let me give you a visualization what will happen if G is below M, and what will happen is if M is below G. So if G is below M, now if this is the free surface, right, and let's suppose this is the axis of rotation, this is G, this is M, metacenter M, and this is the previous bound force B. Now this M, like over this the bound force will be acting, right, because the bound force is connected to this point, this metacenter. So over this bound force will be acting, so bound force in will be in upward direction, and here the weight of the body that will be acting in downward direction. So where the couple will be, like here the couple will be when we'll be connecting these two forces. So can anyone tell me, like, in which direction this body couple will be acting now? I've already shown you the line. So in which direction, whether it will be clockwise or anti-clockwise? Yeah, yeah, correct. So this is anti-clockwise direction. So what will happen? We are toppling it, like if this is the axis, if this is the angle theta, so we are toppling it in this direction, and the body couple will be acting in this direction. That means it is in stable equilibrium. Now, can anyone tell me what will be happening if we are placing this M below G, that is the metacenter will be below G. This is M, this is G, and this is B1. So what will be happening in that case? Anyone? What will happen? Acha, tell me where this G will be, like through G the weight will be acting, right? So what is the direction of that weight?
Ma'am, clockwise.
No, no. This okay, you are telling about that. Like what is the direction of this weight?
Ma'am,
This weight is acting through this center of gravity, right? So what will be the direction
yeah.
of that weight force?
Ma'am, downward.
Yeah, so this will be downward. And what will be the direction of that buoyant force?
Ma'am, upward.
So this is upward and this is downward. So if we will be connecting the body couple, this is the body couple. So what will be the direction of this body couple? Tell me. What do you think the direction is? Where, in which direction you see? You just told me, Sonalina.
Yes, ma'am. I think clockwise.
What?
Ma'am, clockwise.
Yeah. So very nice. So this is in the clockwise direction. Now, this is like we are toppling in theta direction, that means in the clockwise direction, and the body couple is also acting in this direction. So that means it will be displacing more because of the body couple. That means this is in unstable equilibrium. It won't ever come back to the original state. So this is in unstable equilibrium. Okay, so we are done with the basic discussion of what happened in the previous class, what sir taught and all. And the derivations, I have not gone through that derivation in detail because you have already taken the classes. And if not, you just go through the classes. I think I've given you enough description, so you will get an idea. So a visualization, so what is happening. So yes, tell me.
Can you again explain what is the difference between floating and submerged bodies?
Floating and submerged body, nothing. Just a submerged body means a body that is wholly inside the fluid, And a floating body means that is partially inside. That means some part of it will be outside the fluid, right? So in case of submerged body, what will happen? Like if we will topple the body also, as the volume that is submerged in the fluid remains the same, so buoyant force, the center of buoyant force and the center of gravity anyhow will be on the same point only, but the center of center of gravity, center of buoyant force will be same. Like whatever it was in case 1, same will be on case 2. The center of buoyant force will remain at the same position. But in case of floating body, when we will be toppling it, like it we will be doing like this. Now this was inside the fluid in case 1. Now this is the volume that is inside the fluid in case 2. That means what? That means the buoyant force that is acting on the body will change, obviously. Understood?
Yes, ma'am.
Okay. So the center of buoyant force, simply center of buoyant force will be same when it is completely submerged, that is for the submerged body, and in case of floating body, it will be different. That is the center will change, as I have shown here in this case. In this case, the center has, like center of buoyant force has shifted from B1 to B1 dash, where the volume, like as Priyanka correctly denoted, that the when we will be toppling it, where the volume will be more, like if we are toppling on this side, like on this side, then volume will be more on this side, volume submerged will be more on this side. So that's why the center of buoyancy will be shifting on the left direction. But as we are now toppling on the right side, so that's why more volume of the body is submerged in the right side direction. So that's why the center of buoyancy will be shifting onto the right side. Okay. So
Yes, ma'am.
yeah. So now let us move with today's questions. So this is the first question that will give you a basic understanding, like what is happening and what are the forces acting, how to find out that. So this gate, like this is a fluid element, and we can see that there is a gate A, B, C that is present here. Let me increase its size.
Ma'am, question is not visible.
Just 1 second. Is it visible now, or should I increase the size?
So, no, ma'am, not visible.
Just 1 second. Is it visible now?
No, ma'am, that feels only visible. What you have discussed.
The writing also not visible.
Ma'am, I think
Ma'am,
she's facing the same issue as I did in the first class, ma'am. That you told me to pin the screen.
Oh, okay, okay. Uh, yes. Can you like see the screen that I'm sharing? Not the notepad, the other screen.
no, ma'am, only the notepad is visible.
You check onto the participants. Can you open, show everyone?
So, everyone. Yes, ma'am.
So over there, you can see me presenting your presentation.
Presentation.
There'll be one presentation, and can you see that? There will be three
Oh,
icons,
yes,
not
ma'am.
five. So there'll be one
Yes, ma'am.
icon for presentation. So you can pin that. There'll be three dots on the right side. You just pin that.
Yes, ma'am. Okay.
Okay, so both of them are pinned now. You can see the notepad as well as the question.
Yes, ma'am. Yes, ma'am.
Is it fine? Okay. So is it visible now?
Yes, ma'am. Yes, ma'am.
You
Yes,
did
ma'am.
not type the question, right? So that's why it may be a bit hazy, but I think it is definitely understandable. So what is happening is that there is a gate valve, like there is a gate valve, so and there is a water height that is present. So free surface is denoted. So as there is some height of water above that valve, so when that pressure will be applied on this valve, what will happen? It will try to uh, open that valve and to exit from this place, like ABC, right? So can you tell me where the probability of escaping is more? From which portion will the fluid escape in the gate? Anyone? Did you understand what is
Top
my
gate.
question? Yeah, tell me.
Top gate, man.
Yeah, why then?
Because like there is some there is some restriction in the
Restriction.
bottom gate.
Yeah, correct. So our main aim will be, we will try to focus on the top part, that is A, B, and we'll try to bring all the forces onto that part itself. So that we cause there is no possibility of B, like between B, C to for the fluid to escape. So fluid need to escape from AB itself. So what will happen? The whole height of the fluid that is present above this AB part, it will just push. It will just push onto this AB valve or gate, and it will open, and the fluid will escape. Right. So
Ma'am, find it.
yes,
Ma'am, find it from the bottom side.
of course there is. You can see one restriction is there. Na? There is one
Oh,
small
yes, ma'am.
restriction. Let me show you that is. I'll pick it up 1 second. Okay. Just 1 second. This is lagging. Okay. Okay. So can you see
Yes,
this
ma'am.
restriction? This one?
Yes, ma'am.
Basically, I have to show like that only. So you can see that restriction, right? So this won't allow that valve to open on BC direction. So that's why we have to focus on AB to open the valve and the water to escape. Right. So,
Yes, ma'am.
what is it said? To determine the lowest height h for which the gate will open. This h can be denoted here, right? This is h. So we need to find this lowest height h. That can be like we will find for this whole AB portion as it is. And for any point below that AB, like in between AB, for any height that is present, we can say that the gate will open, right? So can you solve this for me? Have you understood what this question wants to say about?
Oh, ma'am, to determine the height.
Yeah, we have to determine the height h for which this gate will open. So gate will open from A to B only. So we have to take the total height from the free surface up to this point B. So any height that will be up to point B, That will help in opening the gate. Below that, because of the restriction, it can't open. Okay, so
Yes.
I think you have understood. So I'll give you 5 minutes to solve this, then we'll proceed with the solution. Okay, solve this. I'll come back in 2 minutes. Okay, have anyone solved it? Are you facing any issue? I can tell me again.
Ma'am, not unable to solve.
Okay, not a problem, not a problem. Others? I'll explain it to you. Don't
Ma'am,
worry.
1 minute, ma'am.
Okay, okay, fine, fine.
Ma'am, I think I made a mistake somewhere, getting wrong answer, ma'am.
No, not a problem. I'm waiting. You can solve it and then we'll proceed.
Ma'am,
Yes, tell me.
actually I tried like whether this method is correct or not, ma'am.
Which one?
What it was like, I
Mm-hmm.
used the formula that yp is equal to yc plus I by area into yc
Mm-hmm.
square.
Mm-hmm. Correct. Then?
Then I took yp as h plus zero point 0.6 because
Hmm. Point.
that is minimum condition.
Yeah. Mm-hmm. Correct.
Yc as h plus zero point
Oh,
0.5.
this won't be point. Yeah, point 0.5 it will be, not point 0.6.
Yp as h plus zero point 0.6, ma'am.
YC, right?
No, yp I took as h plus zero point 0.6. Yc as h plus zero point 0.5.
H plus point 0.5 plus the rest of the thing. Like it will be YC. YC is H plus point 0.5 plus IC upon AYC, right? So that
Yes, ma'am.
so YC is H plus point 0.5 and
Yes, ma'am.
in IC it will be what? BH square upon 12, right?
Yes, ma'am. Yes,
The moment of inertia is BH square upon 12. So B and H is given as 1 1. So it will be 1 to the power 4. That means 1 1 upon 12. So have you done like that?
yes, ma'am.
Then where did you go wrong? What answer did you come?
I got around 266 centimeters something.
I think because like when you were solving, you will get one equation, right? So I think over there you made the mistake.
Yes, ma'am. I
It won't be
think so.
quadratic, it will be linear equation.
Yes, ma'am. I think I made mistake in calculation somewhere, ma'am.
Okay, I'll give you 2 more minutes. You calculate and then we'll proceed. Not a problem. Your approach is correct, like totally accurate. You just check it again. If we will solve one question, because this question is the basis of all, right? So what we will be doing in the next questions also, if we will understand this question, then we can correctly proceed with the others.
Okay, ma'am.
Yeah. Are you trying, Sonalika?
Ma'am, I'm not unable to do that.
See, I'll just tell you how to, like, how to proceed. You try to
Yes,
proceed,
ma'am.
okay? So
Yes, ma'am.
what will happen? See, we want to exert pressure on this one only. Like, let me use some color, other color. Yeah. So on this direction only, because we
Ma'am,
want,
actually,
yeah, tell me.
ma'am, actually, notepad is not visible.
iPad is not visible.
No, ma'am.
So you just again the same way you go to my like you go to the meeting participants. You can see my three icon, right? Three icon by my name. One is the presentation. You pin that and also pin the writing pad one. Can you see? Sonalika? Hello, am I audible?
Yes, ma'am. Yes, ma'am.
Can you see that there will be three icons of mine?
Yes, ma'am.
So in that three icons, see, there'll be one will be for presentation. There'll be two presentations consecutively running. Pin both of them.
Yes, ma'am. I have read.
Have you done?
Yes, ma'am.
Okay, so is that writing pad and presentation both of them visible?
Ma'am, actually, ma'am, I have been but not visible. It only showing your screen.
My writing pad is. Are you able to see, Priyanka?
Yes, ma'am.
I think you unpin both of them and then pin again. You should be able to see both of them.
Now it is visible.
You just go to the participants, you just press the three dots and you can see the pin option in both of the presentations.
Yes, ma'am.
Have you done?
Yes, ma'am.
Okay. So,
Ma'am, I'm getting around 41 centimeter, ma'am.
41. No, it should be 33, I believe. It will be about 33, right? So, it will be in between that 60, it will be uh, above that h we have to calculate, right? So it should be below 60 about. So it should come around 33.3. Yeah, as far as my calculation goes. Okay, let me solve it for you. Like I'll give you first for Sonalika, let me give a brief idea of what is happening. So this this is the gate, like this is a gate, right? But we can't open this gate on this side. Why? Because of this restriction. So we need to focus on this upper portion, that means from A to B. So we will focus the force on FAB on this direction. Now the concept of now we will apply the concept of center of pressure. So it is the point along which the resultant force of pressure due to the fluid column acts in a submerged body. So we do not want the center of pressure anywhere near YBC rather. We want in this AB portion, right? So
Yes, ma'am.
yeah, so this is desirable as we want net force AB in counterclockwise direction. That means in this direction, so that this valve opens. Now, so if we will apply the concept that we studied, just one second, yeah. Center of pressure, this we studied, right? So what we studied over here, YP is equal to YC plus IC upon AYC. So this is the second moment of inertia, and this is the area of that gate valve, and this is the distance of the center of gravity from the axis of rotation. So, and this I is given as BH cube upon 12. Right, this is already derived formula, and this YC is the center of gravity, that will be this height h upon half of this top portion, this half that means half of one though. So it is already told, like if you will go back to the question, it said that the gate in the figure is 1 meter square. That means the height of the gate is 1 meter square. So we'll take off the half of that. That means 0.5. So YC will be what? cause the center of gravity lies in half of the height, right? So half of the height means 0.5 plus this h. So yc will be 0.5 plus h. So this will be h plus 0.5 plus ic means 1 upon 12, because this b is 1, this h is 1, so this will be 1 to the power 4 upon 12, that means 1 upon 12. So this area will be 1 square as it is already denoted in the question, in multiplied by 0.5 plus h. So this is yp. So this must be, so this is yp, but this yp must be less than is equal to h plus 0.6. Why 0.6? Because I have already told you we need to keep it above this point B. That means in between A to B for this valve to open. Right. So this must be less than is equal to 0.6. Less than is equal to 0.6. So if we will solve this, this will be h square plus h plus 0.25 plus 1 by 12 less than is equal to h plus 0.6 multiplied by h plus 0.5. So this will be h square plus h plus 0.25 plus 1 by 12. This less than is equal to h square plus 1.1 h plus 0.3. See, this h square will cancel out. So can you tell me what h will get, Sonalika?
Yes, ma'am.
Solve this and tell me. Priyanka, can you see like where have you gone wrong? I already did the calculation. Can you tell me where did you?
Yes, ma'am, I wrote the formula wrong now. Instead of taking area into yc, I wrote it as area into yc square.
Oh, okay, okay. This will be YC, correct. So, yeah. What answer are you getting, Sonalika?
I'm calculating. I'm calculating.
Okay, okay. Do that.
Ma'am, 0.33.
Yeah. That is meter. So, it will be 33.3 meter. That means option, sorry, centimeter. That means option C. So, this will be less than is equal to 0.3 meter. That means 33.3 centimeter. Okay, let's proceed to the next question now.
Ma'am, how to identify from the question that here the concept of center of pressure is used?
How to identify, like here it is told, no, like as we can see from our concept, like let me show you here. So it will be, so in this kind of question where a body will be like submerged, or some body is there, some from other point some pressure is applied, right? Like in this case some valve is there and some pressure is applied and the fluid is static. So when this fluid is static, we can apply this point, center of pressure concept. So that will help us in direct solving, like without going into much derivations and everything.
Yes, ma'am.
Okay. So so let's solve this question now. So what is it told here, that as we went through that curved surface that is submerged in the fluid. So here this BC is the quarter circle, that is also a curved surface, that is it is into the paper. So that is submerged in this fluid, right? So it is given that what is the like as we already know, like what are the equations that will be applied. So tell me, what is the horizontal component of the hydrostatic force that will be applied on this gate BC?
Ma'am, FH and
Solve this for me. We already, like, let me go to the formula. Just one second. Yeah, this is for the curved surface, right? So what we will do, we'll just find this FH and FV. So when we will do
ma'am,
for
which one?
FH, so it will be rho. Just one second. When it will be FH, as we solved for this surface, it will be rho g into area into HC, right? HC is the center of gravity from the free surface. So half of that, half of the height. So it will be half of the height. So this FH will be, just one second. Yeah. So this FH will be rho g area into, as we have seen that from the derivation, into HC. The height from the free surface. The height of the center of gravity from the free surface. Can you solve this now? Just the horizontal, like, is it's already visible in the diagram, right? So where the horizontal force will be applied by the fluid, like what is happening, this is applied by the fluid on the right side to uh, the gate, to the valve that is present, or the gate that is present. Can you solve this,
Yes, ma'am, you can try.
Priyanka? Have you solved?
Ma'am, 60 kilonewton, ma'am.
Yeah, yeah, correct. So let us wait for Sonalika, let us solve. I'll come in 1 minute. Hello, have you solved it, Sonalika?
Yes, ma'am.
Yeah. So have you got 60 kilonewton?
Yes, ma'am.
Okay. So it's nothing like density will be what? 1000 and G,
1000.
yes, G will
10.
it's written 10. Yeah. So it will be area will be 2 into 3 with this 3 meter. So
Yes, ma'am.
this
2
will
into.
be half into 2. So this will come about 60 kilonewton. Option D. So can you tell me what is the vertical component of the hydrostatic force? That's very easy. So I won't be solving it. You have to solve. Vertical component means the weight of the body, right? The weight of that gate. As we have seen that vertical component is only represented by the weight of the body. So can anyone solve it, Priyanka?
94.25 kilometer.
Yeah, correct. And Sonalika, solve it. Let's see. And give
Yes,
answer.
ma'am.
Tell me. It will be just the weight, nothing else.
Ma'am,
Yeah.
ma'am नहीं हो रहा है.
Okay, okay, not a problem. So, okay, let's solve this then. So FV will be what? It will be density into density into volume into G. So density is 1000, mass into G, right? The density into volume. So this is pi r square L. So this is just a quarter of cycle. So it will be 1/4 of the area. Sorry, total volume, right? So for a circle, the volume, sorry, it is a cylinder. We will consider this a cylinder because this is extended in 3 meter width, right? So we will be considering 1/4 of that cylinder because it is quarter circle. So for cylinder it is pi r square L and we'll consider 1/4 of that cylinder. So 1/4 of pi r square L into 10. So this will be 1000 into 3.1416 into 2 square into 3 upon 4 into 10. So this will be 94.25. Have you understood?
Yes, ma'am.
Yeah. So if this is the free surface and this is the gate, right? So this is the projection, this is the horizontal projection, this is the vertical projection of that gate. So this is point B and C, this is the pressure. So what does the next question say? The next question say that what is the horizontal pressure or force P required to hold that gate stationary? What is that horizontal pressure that is required so that this water that is on the right side that won't cross that gate? So neglect the weight of the gate. So vertical forces will be neglecting. We'll just consider the horizontal forces. So what will be the pressure that will be exerted? Anyone?
Ma'am, 60 kilometer.
Yeah, very good. It's accurate. It's exactly correct. So Nalika, have you understood what we want? So there is a right side, right? So on the
Yes, ma'am.
right side of this valve. So this will be exerting some force on that gate valve. Just 1 second. This will be exerting some force on that gate valve here. So what we want to apply one pressure P or force P on this side, so that this valve or this gate valve, this gate remains stationary. So what will be that force P? This is the question. Tell me. So it will be just equal and opposite of that. This is the vertical force, but sorry, vertical force, right? So in this direction there will be vertical force, and in this direction there will be horizontal force. So it will be just the equal and opposite of that horizontal force, right?
Yes, ma'am. 60. So,
Yeah. So it will be 60 kilonewton, simple. Let's proceed to the next question now. So we don't have much time.
yes, मैम एक्चुअली मैम एक स्क्रीन अगर मैं पिन करता हूँ तो दूसरा मैम शो नहीं करता, इसलिए मैम बहुत सारा प्रॉब्लम आ रहा है।
तुमको दोनों स्क्रीन पिन करना पड़ेगा, लाइक
मैम यस मैम, वो मैं दोनों ही पिन की हूँ, लेकिन अगर एक को मतलब पिन करती हूँ तो दूसरा मैम मतलब उसका स्क्रीन दिखाई दे रहा है, लेकिन आप जो लिख रहे हो वो कुछ मतलब शो नहीं कर रहा है।
सो क्या
मे बी
करो।
नेटवर्क इज।
ओके, तुम अभी लैपटॉप में नहीं देख रहे, फोन में देख रहे हो, राइट?
नहीं मैम, लैपटॉप से ही।
पर फिर तो दोनों विजिबल होना चाहिए था, लाइक हाँ, थोड़ा छोटा दिखेगा तो थोड़ा देखने में प्रॉब्लम हो सकता है। एक काम
यस
करो
मैम।
तुम, पर लैपटॉप में उतना तो प्रॉब्लम नहीं होना चाहिए। तुम अगर साइड वाला जो पार्टिसिपेंट का आइकन है, तुम उसको बंद कर दो।
यस मैम।
Okay, so we'll proceed to the next question. So what it said that a plain gate of uniform thickness holds back a depth of water as shown. Find the minimum weight needed to keep the gate closed. So what is said that there is a gate that is present, that is shown with this length L, right? So it is used to trap this water rather. So it holds back this water. So what is the minimum weight that is required to keep that gate closed? So it is given that the density of water is 1000 and gravity acceleration due to gravity will take 9.8, simple. So the same concept what we have already studied till now, we will apply this concept over here. So can you tell me how to solve this? What is the approach for solving this?
My moment about the hinge point should be zero, ma'am.
Yes, that is true. And another? So what is the moment? Like how should we calculate that?
Moment like here it will be like if we calculate about the hinge, it will be due to one will be due to weight and the another one will be due to the water pressure.
Correct. So if we will solve this, then if the moment about that, if I consider this as zero, I have not drawn it. If I consider that this, let me draw this first. So if this is the point and this is the gate, this is the force that will be acting on the gate, and this is 30°, this is L. So this is the weight of the gate, right? So this is L by 2 where the center of gravity will be acting. So what will happen, this is width is 2 meter. So what will happen is that the moment about this point 0, that will be 0, right? So one will be the weight that is acting on L by 2, that is the half of that half of the whole length of that gate. and cos theta. That means it is weight is in vertical direction, right? So we are just taking theta so that we can take in that direction of the gate. So this will be integration of y df. This is the interaction between the fluid and that gate. So this df is what? Df we already know that it is pda. P is equal to rho g h. That means rho g y sine theta. This we already know. We have already derived this. So df will be, so if we will put it in the main equation, y rho g y sine theta d. Okay, so this will be the equation that will be solving. This will be the equation that will be solving. If we will solve this equation, so this will be from 0 to whole length of the gate. So if we will solve this, we'll get the value of w. So that is the weight of the gate that is required to keep that in equilibrium. So can you solve this? What will be the answer?
So, ma'am, can you please explain again, ma'am? The screen problem is there, so
Nothing, like this is the like, let me use some other color. If this is, if oh, if this is the point where about which the weight we need to calculate, right? So this is the whole gate that we the weight of which we are considering. And if we will be calculating moment about this point o, that should be zero at equilibrium. Simply, everything at equilibrium should be zero, the summation of all forces. So here two forces are acting. One is the force due to this weight of the weight of this gate. Another is force due to the interaction between the fluid on this side and this gate. So this force is given by this df, and the weight is given by this w. So if we will be equating both of them, we can solve this to get the value of w. Understood?
मैम थोड़ा एक बार मैम नेट कनेक्शन के लिए मैम सुना ही नहीं दे रहा था.
ओके अभी समझ आया ना? ये जस्ट वी नीड टू लाइक, यहाँ पे दो फोर्सेस है, राइट? वन इज द वेट फोर्स,
Yes,
अनदर इज द इंटरेक्शन बिटवीन, जो अभी तक हम पढ़ते आए हैं, द इंटरेक्शन बिटवीन द फ्लूइड एंड दैट
yes,
गेट. सो ये दोनों को हम सिंपली
yes,
इक्वेट
ma'am.
करेंगे टू मेक द मोमेंट जीरो. तो मोमेंट मतलब क्या होता है? दैट फोर्स इनटू द डिस्टेंस अबाउट दैट हिंज
Distance.
पॉइंट. द यस, द हिंज पॉइंट जहाँ पे वो वर्क कर रहा है. तो हिंज पॉइंट क्या है यहाँ पे? ओ. और
Oh, yes,
फॉर,
ma'am.
यस, फॉर वेट ऑफ द बॉडी, क्या होगा विद इन. सो द हिंज पॉइंट क्या है? वो वेट ऑफ द बॉडी एक्ट करेगा इन द मिडल ऑफ दिस गेट, राइट? सो दिस मिडल ऑफ द गेट, दैट्स व्हाई वी आर टेकिंग L/2 हियर.
Yes, ma'am.
एंड दिस इंटरेक्शन फोर्स इज ऑलरेडी वी नो दैट इट इज pda, क्योंकि हमने ये बहुत बार डिराइव किया है. सो दैट विल बी, तो हम ये दोनों जब इक्वेट करेंगे, we'll equate it throughout the whole length of the gate to get an idea of what will be the weight that is needed to be considered here. So you solve this and tell me the answer, what you are getting. What will be the weight?
Yes, ma'am.
Yes. Priyanka, have you solved?
Ma'am, 34 kilonewton.
Mm, check again. Check again. There is one mistake.
Ma'am, what is the value of y?
Value of what?
Ma'am, y.
Hello?
Ma'am, y.
Why?
Yes, ma'am.
Why you have to integrate? No,
Oh,
you
yes.
can't get the value of it. This is what that is unknown. So when you will integrate from 0 to L, you will get the value of W.
Yes, ma'am.
Okay, have you solved it? Okay, let me solve this for you because we need to do at least one more question and it's already very late. Okay, so what will happen? This W will be 2 rho 2 rho G. This will be 10 theta W L 0 to L y square dy. So this will be 2 rho G W 10 theta L square 2 by 3, sorry. So this will be 2 by 3 into rho means 1000 into G means 9.81 into W width is given as 2 into L square length is given as free square into 10 30 degree. Okay, so this will come about to be 68 kilonewton. Okay, so let us proceed to the next question. Is it visible?
Yes, ma'am.
Yes. So
Ma'am,
okay, yeah, tell me.
ma'am, one second, ma'am. वो जो W आपको ये मैम
Hmm?
मैम जो W आपने जो ये जो 2 रो G tan थीटा में मुझे W मैम कैसे
W कैसा मतलब? This W
मैम
is different. This W is weight, and this
wait
one
yes
W is width. Width of the this width is given na 2 meter.
wait yes ma'am yes ma'am
Okay. So there is a gate used to control the water flow from a dam on as shown in the figure. So that gate width is 35 meter. It is given that the density is 1000 and acceleration due to gravity is 9.81. So first we need to determine, so it is similar to the previous problems. So first we need to determine the horizontal force and then the vertical force and then the line of action of the force from the water on the gate. So can you tell me what the horizontal force is? How to calculate? How to proceed about this question? Anyone? Priyanka?
Ma'am, rho GH3 into A for horizontal force.
Roji, what will be
it's
the
Into
C
A?
5. 5. 5.
So what will be that h?
5, ma'am.
5, ma'am.
No, actually. So so it is the pivotal point is this hinge, right? So here it will be we need to consider sine theta. So we have to change that height to theta, sine theta of that. Understood? So it will be r sine theta. This will be
Yes,
the
ma'am.
this won't be that height, right? H, right? It will be the distance from that gate to the pivotal point, always. Understood, Priyanka? So it will be r sine theta. Yes, tell me. Hello, Priyanka.
No, ma'am, doing, ma'am.
Okay. And also another thing is that the force also in the horizontal direction, it will be f cos theta, because uh, we need to find it in the horizontal direction. So the force that we are finding now will be in at a theta angle from that horizontal. So we need to find in theta direction. So this will be df cos theta. So what we will be finding out, that will be df cos theta in the horizontal direction. Understood? Because we are finding that out in the pivotal direction, right? Try and solve this. I'm here only. Okay, so have we solved it? The horizontal force, what will be the horizontal force? Sonalika? Priyanka?
मैम थीटा वैल्यू क्या लेंगे?
Theta will be, see, I'll show you this. This is the gate. This is 10 meter.
यस मैम.
And see, this is theta, right? This is theta. Oh, my handwriting is so bad. Let me draw it again. See, this is some theta, and this is the gate actually, and this vertical distance is 10 meter. And if this vertical distance is 10 meter, and this r is this r is 20 meter, right? So if we will consider this triangle, this, like, let's suppose this is 10 meter and this is 20 meter, then it will be sine theta. If this is theta, sine theta will be this upon this, that is 10
10
upon
by
20.
20.
So theta will be sine inverse 0.5, that means 30 degree. Use this as theta.
Yes, ma'am.
Priyanka, have you solved?
Ma'am, 1.72 into 10 raised to 7 Newton.
1.7, yeah, correct. Can you solve for the vertical force?
We'll try, ma'am.
Okay. Again, it will be in consideration of the angle, right? So we will take the angle into consideration to find the force. Do that. Have you solved, Priyanka?
Ma'am, just a minute.
Okay. So Anlika, have you solved?
मैम एरिया में थोड़ा प्रॉब्लम है जो एक पेज में जो हॉरिजॉन्टल फोर्स में
Hmm?
मैम वो जो मैम जो हॉरिजॉन्टल फोर्स है ना मैम उसमें जो एरिया मैम वो थोड़ा
एरिया में क्या दिक्कत हो रहा है?
मैम वो 835 अप्लाई रहा हूँ तो मैम आंसर नहीं निकल रहा है
Okay. I'll solve it for you. So area यहाँ पे हम ये एक arc है, right? So we'll take the area of the arc only.
बाय यस मैम
So area of the arc is WR d theta.
यस
WR d theta. D theta means the angle. So we will just integrate it later on. So W means the width and R is the radius. So if we will solve this, DF horizontal will be DF cos theta. So that will be pressure into dA cos theta. Why cos theta? Because this will be the horizontal direction. So we will take this to angle theta, right? So we are finding it from the pivotal point. So we have to take it to the horizontal direction as well. So, so if this area is dA, so dFH will be rho GR sine theta WR d theta cos theta. So why sine theta? Cause this P is itself is by formula we know R sine theta. So this will be like that. So yeah. Now FH will be is equal to 0 to 30 degree. Theta is 30 degree. Rho G R square W sine theta cos theta d theta. So this will be is equal to rho G R square W integration 0 to 30 degree sine theta cos theta d theta. So if I'll divide by 2, we can multiply by 2. So this will be sine 2 theta So this will be rho g r square w. We will integrate it, so it will be 30 degree sine 30 whole square by 2. So this will be rho g r square w upon 8. Okay. Now the horizontal force is equal to, just 1 second, I did something wrong. Horizontal force is, yeah. So we will just put on the values now. So density is 1000 into 9.81 into 20 square into 35. Width is 35, length is sorry, our radius is 20 square. So this will be 1.72 into 10 to the power 7 Newton. That is option C. Can you tell me about the vertical force? Have anyone solved it? Yeah, Priyanka?
Ma'am, 6.2 into 10 raised to 6 Newton.
Yes, correct. So this will be same, right? So this will be df. 1 second. This will be df sine theta. So this will be p dA sine theta. Similarly, when we will be solving it, we will get 6.2 into 10 to the power 6 Newton. So this, so the next we have to find the line of action of the force from the water on the gate. So what will be the line of action? That will be simply tan theta is equal to this, this vertical force is Fb and this horizontal force is Fh. So Fv upon Fh. Have you solved it, Priyanka? Sonalika?
Ma'am, option B.
Option B, yeah, correct. Sonalika, have you understood?
Yes, ma'am.
Yes. Okay. So this is tan inverse Fv upon Fh. That will be is equal to tan inverse, we just put on the value. So alpha will come about 19.8 degrees. Okay. So this is nothing, like let me show you what this alpha is to get an idea of what is happening. So this is the arc and this is the free surface. So what is happening, if we will this is theta, right? So if we will magnify it, so this is the direction where FH is acting, this is FV is acting, so this is the resultant force and this is alpha. Okay, so yeah, so let us solve for one more question. This simple like problem kind of. So after that we'll end today's class. So it's already 15 minutes late. Mm. Okay, so can anyone tell me what will be the answer to this question? If B denotes the distance of center of buoyancy from the free surface and G denotes the distance of center of gravity from the free surface, mm, then which among the following condition ensure the stable equilibrium? Is center of buoyancy less than gravity, or buoyancy greater than gravity, or equal?
Ma'am, A.
Yes. Okay. For the second case, for unstable equilibrium, it will be just the opposite.
B, ma'am.
Yeah. And it will, for the neutral case, for the neutral equilibrium, which one will be the option? Option C, right? Okay. So you have got a clear idea of what is happening. And should we go to that much detail now? I think we should end it here because it's already 20 minutes late. You can mark, like, you can get a screenshot of this too. Anyhow, I'll be uploading the videos. You can check out the YouTube. That will be given on your NPTEL website. So, SWAM portal. So, these are the next two questions. If you have any doubt, we can discuss it on the next class. Okay. These are the three questions that I'll let.
Yes, ma'am.
Okay. So, okay, thank you for joining. I'll end today's class. I'll meet you all same time on the next week. Bye bye.
Thank, thank you, ma'am.
Welcome. Bye bye.